Hello, I'm George Gonzalez, and I'm obsessed with making games. And today is Multiplayer Monday. So we're going to go over networking a dragon, and it's actually pretty cool. So if you have, and this applies to anything, even if it's not VR, or if you want like a snake, like movement in the air, on the ground, 2D, 3D, whatever you want. This is probably the more complicated version, and then you can always tone it down to something simpler. But here we go. Let me show you what we have so far. I'm in a build on my headset. As you can see, I'm here and I can move. And on the ground is the other player, as you can see in here. That's the rig right here in the editor. So we have two players. I'm not going to display what I see in my headset because it'll be the same, and there's no point in the syncing. You'll see the delayed version as much as you can. It's not delayed by a lot, and so I think there's no point in showing you both angles. But I just want to show you that it does work, because right now what you're seeing is the client, what the client will see. And if you want to test this game, I'll post a link below and you can join the alpha channel and test these out yourself. So here we go. I'm going to do the spell, and you can see I can control it. It's going right, and then it's going to go down now. And I control it with my headset. So all the rotations, I can go as crazy as I want. Let's see another one. I'll do it to the camera maybe, so you could see it from a different view. And then it comes back. Let's see if I can bring it back. Oh, I can't. It's so hard. It's really hard to manipulate, but it's super interesting. I should have done less mana for it. But anyway, so you'll see the effect. Oh, and I forgot to bring it back. I forget to do that sometimes. But that is it for the spell. You can see it syncs the wave-like movement on both my headset and in there. And so now let's dive into that and what it takes. Okay, so we have a dragon. It's called Earth Dragon Bullet 2 because I was testing different things. But I split. What happened is that usually when you have a rig, you have the bones are children and it's animated, right? But in this scenario, I wanted to control everything. And in order to create a smooth snake-like movement, I needed the bones to be aligned. And so some of these have children that don't require any alignment, but they still need to be parented because the mesh requires all these bones to be somewhere and to be where they need to be. The other thing is that I do need to adjust the distance it follows because, as you noticed, this is stretched out a little bit. But the idea is that this dragon, you'll be able to, the shader actually changes where it appears. And then we'll cover that in the non-network video on Thursday, and I'll show you the shader for this. But the idea is that the shader has controls. I have world position and rotation, so that way it aligns to where I spawn the dragon. Okay, but the main thing we're looking at is spawning the dragon and controlling everything over the network and what is going on. So we have this dragon attack that spawns, and we have these dragon colliders that deal damage, and we have mesh render. So this mesh render is what controls the material. Let me double check. This is the skin, I believe. Yeah, the skin mesh render. And these are the other items that we might not need, but I don't want to delete them. The main thing is we have this. This is the head. See, as you can see, it stretches out. That is where we start. Okay, so we have this head collider. What's going on is that we don't move the bullet, even though it says bullet. We used to at the beginning. And what happened is that if you had children and you had the movement based on the parent, and as I rotated the parent, the children would rotate, and so then there would be this offset that would happen, and it would jitter a lot because it was fighting between the parenting, controlling the rotations, and the children doing something else. And so in order to keep that smooth follow, I decided to do per bone movement and separate the logic. You could go the route where you're just changing the rotation. The only problem is that the bones are not moving on that parent because the bones are glued, and so in order to move them physically, you'd have to move them ahead of, like with the parent. So there's a lot of things that you would have to adjust for controlling bones, and so I didn't want to control the bones in that way, fighting the parenting. So what I did is I have a script that's called the bone follower. Okay, where it's right here, and this bone follower is actually not networked. Okay, so there's two parts. There's the head that is networked. The head, where the head goes, is networked, but the rest of the bone followers are not networked because I didn't want to waste bandwidth networking each individual bone because that is a lot of bandwidth. So this is very effective for saving bandwidth on a network solution. Okay, so we have a network transform. So let's go over the bones. So we have the bones, and all the bones do is follow. And yes, there's like other things that I have in here that I eliminated because we didn't need. But we have this transform data, and most of this was done with ChatGPT's help. We had a queue and history size. So if we wanted to like store, we don't need that many per second. Okay, this was just a safe measures. We can always tone it down, and we have a setup. So what happens is this is done at runtime on every child the moment it spawns. So it says, okay, do you have a target to follow? If you do, this is the current position. We start the queue, and we have the delays. And then on fixed update, we record the target transfer and update the follow positions. So all we're doing is we're adding to the queue, and then we are updating the follow position based on time, okay, and the follow delay. This, I would say, if I was like polishing this and I needed to say, okay, this needs to be better, more efficient, less, more performant, I would say we don't need a full history. We just need a delay on when to grab the transform position, or grab the transform positions and then say like the delay. So there's less buffer values in between, because maybe we just need like a delay by frames instead of by time, right? And just adjust it to be more performant. So that can be done. But right now, the point of this is to get it working. Okay, once we have it, because at first it wasn't even smooth. And so I'm trying to share with you what is that is working, because it actually is pretty smooth. It's stretching a bit, so we can adjust that later. But right now, this is working for the bones. So it gets the interpolation between the length, and you can pause. Let me see. Let's put here is the return for the transform data for get interpolated transform, and then they apply the distance constraint. And then we had a draw gizmo, but this actually I'll never use because it's not valuable information for the most part. Sometimes it was. So this, most of it was ChatGPT. Obviously, is not perfect because ChatGPT just adds so much more. But for this got the job done. And then you notice that I did a lot of changes and corrections. Now, there's times where I didn't want to do the movement update, and then I would just edit this out, and I would just do rotation if you wanted to just control the rotation. So let's go, and I'll show you in here. We have each one has a bone parameter, and they all, if I go and drag in bone follower, and we change all these, for example, the smoothing factor doesn't have to be 20, probably like 5 could be, and it doesn't need to be super. There used to be, so again, we have this distance constraint. We don't need that to see, like if it goes a certain distance, then update it. It's just like a backup. Now we have the follow delay, 0.05. These could probably improve to be like 0.01 delay because it's stretched out too much. So if it's stretched out too much, I just need to, the delay needs to be less. And see, the values are so small that I would think I would just do it per frame and just do a number for the frame update so that you don't have super small numbers, because you don't need to, again, it's just so small. And you don't need many values. As you see, like smoothing factor, like we can tweak that. So we could, now that it works, I can go and tweak these values to see what we really need, what we don't need. As you notice, like ChatGPT gave me a lot. I can just take out the fluff and clean it, because I love the least amount of color that I can get. Like if I can trim and get the same results, great, because it's easier to understand, easier to deal with, and debug in the future. So anyway, so this works. We have colliders for dealing damage and other things that we do. But the main thing is that we have the bone followers. The next part is spawning the dragon and moving the head, because that is the thing that's network. That's the key. And a lot of the headaches come from network transform. Okay. When you spawn something, you need to make sure you just can't assume that network objects will spawn where you want them, unless there's something that tells the network object to spawn at a certain time. So when you read documentation, or you, depending if you're using Unity network for game objects, or Fusion, or Fishnet, Mirror, whatever it is that you're using, you have to understand, okay, if I spawn something, what is the logic, or what do I need to do to make sure that they both spawn in the same place? Is it automatically handled by the system, by the network solution? If not, what do I need to do? Because in Fusion, I've said this in multiple videos, it doesn't. And so the easiest way is to just put a network transform and it's done. Ideally, and I think it does some caching. So like if this doesn't move anymore, it won't update. So it's performant, what I'm saying. So you don't need to like reinvent the wheel and do it yourself, because you just need it once. Because when you spawn an object, you only need the spawn position once when it spawns, unless you're moving it. So anyways, but this makes sure that when you spawn a dragon, everything is spawned in the same place. Because you see this, how even though I'm moving this on itself, and you see I have a network transform, because this guy is going to be moving. Even though this is networked, this is parented to this. So when it spawns, it needs to be in the right location, like so that everything's correct. There's no offset. There's nothing wrong. They're both in the same place, because that will cause issues with this. So next, we have the network transform here. The rest of the stuff doesn't have any network transform logic. There's nothing networked about these things. Like you saw, I even had this on fixed update. If we go in here, we have fixed update. That's where we do things. And if it's not set, it's not going to do anything. So it waits for us to set up the bones before it does anything. So it doesn't go crazy when you spawn it. Because sometimes when you spawn the rig and there's logic, it's going to start messing with the animation and it's going to look weird. So anyway, so we set it up. Again, we have the setup. And this setup is happening in here. And it sets up in both the client and the state authority, because this is for both. So the idea with this is that we have the initial head and controller rotation. And on fixed update on the network side, we update the head. So a snake head controller. So I used to have other ways to control it, like a joystick. I also had like a WAS key to test it. And so I had a lot of functions that did the same thing. So we ended up with this. This is the final one. Snake head with controller. So it uses a controller movement and we update it. And this only happens on the master client, on the person that has state authority over the spell. So I spawn the spell, I control the head with my controller, and it'll know if it's right or left controller. I pass that as a parameter. So we have all that. See, when we set up different things, we have the world position, the forward direction, and the controller transform. And so these things are set up at the beginning of the game, at the beginning of the spawn, before it spawns. And so the master client controls the head. The head is networked. And what happens is that we've set up all the clients. So all the clients have the bone. And technically, like, it could be off. Nothing's synced about the bones. The only thing is that they started at the same time. And so what will happen is that even if, let's say, someone comes in the middle of my dragon spell, this setup is going to set up those bones. So the moment the player comes in, he'll see the dragon spawn. It will spawn and it'll follow this logic. It won't do anything of this, but it's networking the dragon's head. And what will happen is on spawn, it will set up the followers, and it will take like a split second, and then it will line everything up with the dragon. So the bones will be transformed where it needs to, and then the followers, because there's that setup that happens, this setup places the transform where it needs to be. Okay, so it goes and it moves where it needs to be. And then from there, it just does the same thing. And so the one thing that I could test is having people hop in and out and be casting the spell at the same time. It's really hard to like replicate, because you have, like, there's a 5-second window when the spell lasts. And it's not a huge deal, because again, when a player is spawning, they're not going to be like, oh, where's the dragon or where's the spell? So they're not worried about that. They're trying to orient themselves. And so it's not a big deal. It's just like a split second where they might see something jittering. And in that case, you could do something to buffer or not show things. Like the setup thing could also be like enable and disable the mesh until everything's set up. So you could do certain things that will trigger and wait for the setup before you show the dragon, for example. And so that when the dragon appears, it's all set up so you don't see the jitter. So those are options that you have to polish this. But we're not, the first task is to make sure it works. Don't worry about dealing with like performance issues until you have something done. All my spells that are networked are super inefficient and non-performant. There's like no pooling done. Some things where I could, I tried, for example, like I'm not networking all the bones because I didn't want to have that solution and then change it to a different solution. That is something that I wanted to do early on. But the other things with performance, I can always update and change. But the first thing is I want the game to feel good. And then I'll figure out what we can do for performance. But first, focus on the fun aspect of the game. Can you get it done? How do you do it? Okay. Again, we have a state authority that deals with the head, and then there's logic for the bones, and it's all client-based. And it sets up right here. And so this is crucial, is understanding how to manipulate network objects and when you do or don't need to network something, and doing it correctly, because I have to set up, I make sure that this is on fixed update, has state authority. I don't think this function runs on the client anyways, but I just like to be cautious. It's just a habit of mine. And so we always check if it has state authority so there's no errors. And then we do the rest of the other. And again, we have setup scripts. So a lot of times with network objects, you will run code. You'll create a lot of code and not think about dependency or timing. Or you might do it manually by doing these wait functions and stuff, but it's not needed. Do not do these crazy setups, because that's what I would do at first. I would have on spawn and I would have all these like Booleans or checks or events that I would fire, and they would fire back and forth, and so that the client would know when it's ready and whatnot. If you need something, make it a network. So see this is networked, the world position in the forward direction for the material. And we'll look at that material in the next video. But this is how we set up so that way the cutoff position and direction are networked across both the client and the material is affected on all of them. So all we're networking is the location of where the dragon is spawning. And it's network. So we don't have to like send events and whatnot. That's what they're there for, is so that way if someone spawns halfway through, the material will work regardless. We have all these things that need to happen. We save them locally. And again, we have the setup, always set up, and we have this setup position that happens on the spell. So let me show you is we spawn a network run, and we have this delegate function that happens before we even like run the spawn. So every solution has a way of doing this where we can almost like pre-warm and prepare the asset for when it's spawned on the network object. And so this is how Fusion handles it. And so I have this options to say, hey, set up the dragon. And here's what we give it, where we're spawning it and the controller. It's pretty straightforward, but again, it might not be so much if you don't have experience with networking solutions. And that's why I'm doing these videos, is to so that you can understand what you need to do to think about these logics that you're going to create in your games. Because you might come up with things that I'm not doing, or you want to do something in a very particular manner. Well, now you know how you see the options that you can do. You have setup functionality that you can do for before spawning. You have network variables if you need to make sure that all clients know something. Or you also have setups that you can create in children to then let it handle itself. Because again, the head is network, so that will sync across everyone. The head is, and then the bones will just follow. It's kind of like a domino effect. And so I don't care, because you saw the distance difference, like 0.05. It's so little that as long as the bones are following each other, it'll be smooth, even if it's delayed. But it won't jitter because it's all local. So the only jitter that you might see or delay will be from the head, but the rest of the body will be nicely synced because it's happening on your headset, on your controller, on your side of the things. And so that makes it so that the look, it's smooth, even though it's not networking everything. And so it's an illusion. And so sometimes you can create those kind of illusions to make your game better, and so that it looks more polished, even though it's not under the hood, right? It's all about perception. Hopefully you like this. And next, on Thursday, we will go over the shader so that you can create cool shaders that maybe adjust based on position or rotation. So we'll see you next video.